In this video, we're going to take a look at quotient graphs and a reduction theorem. Let's define a quotient graph. So let G be a graph on the vertices V and E. Let E be the edge between V and W. That's some edge living in our edge set, and V and W living in our vertex set. The quotient graph, GE, is the graph obtained by merging V and W into a single vertex and combining any edges that happen to be superimposed in the process. So let's say that we have some graph G here. So this is our graph G. Let's call this edge E. So we are going to find the quotient graph GE. And what we're doing is we're taking along this edge E, we're just going to merge the two endpoints of that edge. And so when we merge those together, over here, that initial portion of the graph, it stays identical. But what's happening is we are pinching this point down to there. And so as we pinch it down, then it ends up lying directly on top of this point. The edge that was from here to here, it ends up lying exactly on top of this edge here. Right, so they're going to just be merged into one. We still have that edge back to there. And so this would be our quotient graph, GE. Great. So that's a quotient graph. Those show up from time to time. Graph theory. Another thing that we have is if G with a subscript of E, this is a denote a subgraph of G with the edge E removed, but the endpoints left in place. So here this is not, this notation is not the same notation, it's not a quotient graph. It is a subgraph where we've just deleted the edge. So we haven't merged the endpoints, we've just removed the edge. We've left those endpoints in place. It is the same as our original graph in every way except for that single edge has been removed. And so if we were to look at our chromatic polynomial, it's the chromatic polynomial of that reduced, of that subgraph with E removed, minus the chromatic polynomial of the quotient graph on that same edge. So let's find PC4 using the reduction theorem. So C4 looks like this. Let's go along this edge. And so C4 with that edge removed looks like this. All right, so that's C4 with the edge removed. PC4 with that edge removed. We'd have X, and then you'd have X minus 1 options for each of those other three vertices. C4, the quotient graph of C4 along that edge E, if we were to take and pinch those top 2 points together, you'd end up with this. So you have X times X minus 1 times X minus 2. And so if we wanted to know what is our chromatic polynomial for C4 itself, it's going to be x times x minus 3, x times x minus 1 to the third, minus x times x minus 1 times x minus 2. So that is our chromatic polynomial for C4, and we can find that using this reduction theorem. Fantastic. So that's our last new thing. As homework, you have this mess. And so you can try those on your own. All right, we will talk to you later. Have a good one.